Alright guys, today I'm going to walk you through the UT lab. This is for part 1 of the flood lab. First thing you need to do is you need to have the worksheet that I handed out to you in class in front of you. It looks like this. If you don't have this particular worksheet, you can get it on Schoology or on the Canvas site right here. I'm going to make the assumption that you've already read the first 2 pages of this particular packet. If you haven't, you need to pause for a moment and read the information as kind of an intro to what you're going to be talking about. Essentially, here's what the lab entails. The lab is going to be taking a look at a city in Texas called Grand Prairie. You can see where Grand Prairie is. It's a convergence of a bunch of different rivers, often used for recreation, fishing, whatnot. Oftentimes, though, the actual river becomes flooded. So this is a picture of the actual flood within Grand Prairie. So your job by the end of today is using different data is to create a flood map similar to this. This one is not Grand Prairie, this is another location. I'm just showing you where rivers converge based on the 10-year and the 100-year data. You're going to figure out what the floodplain is, and you're going to predict whether or not you should build within a certain different locale based on that data. The data that you're going to be using in Excel, you're going to be graphing different things, comparing the discharge within an actual river. If you remember, the discharge is simply the velocity coming down in combination by the area. You're going to be using that data in conjunction with gauge data. This is how high the river gets at any particular rain time. From that data, you're going to compute what the 10-year flood risk would be and the 100-year flood risk would be. So right now what you need to do is on your lab sheet, you need to answer question number 1. We discussed this in class and it will be asked on the UT lab submission. It says to define a 100-year flood. So if I look at my lab sheet, it says question 1, define a 100-year flood. Remember, in order to figure this out, I need to figure out what is my probability of having a flood in any given year based on the fact that I'm in a 100-year flood zone. And then write down your answer here. If you're not sure, refer back to your notes. So pause here for a moment and define 100-year flood. When you're all done with that, now we're going to use the flood records on the Excel spreadsheet. The discharge is going to be in Q, which is going to represent cubic feet per second, and this is the largest flow in any given year. So in a minute when I open my spreadsheet, it's going to look like this. This particular column is the discharge. Remember, that's the velocity and the area for any given year. Then I'm going to take different years from 1925 up until fairly recently and compare it to figure out what my 100-year flood zone is. There's not quite 100 years in there, but I'm going to use that data that we have on record to figure out that zone. Alright, so the first thing it says I need to do is I need to count the number of years on record. So if I go over to Schoology, I'm going to be walking you through Excel. If you do it on Google Sheets, it's slightly different, but it's pretty similar. So I'm going to open up the Excel application. Once the Excel application is open, I need to enable editing. And I need to scroll all the way to the top so I can see those labels. So they've already put in the data for you. So again, here's discharge, here's the gauge height, here's the year, and here's the exact date it was measured on. Again, it says the first thing I need to do is count the number of years of record. This is incredibly important because I'm going to be using this number in a minute in an interval equation down here, where n is the total number of floods on record. So I'm simply going to go into my spreadsheet. Starting with this year, I'm going to go down and I'm going to count them. I'm going to record that number on my actual lab sheet right here. Now I'm going to determine the ranking of the floods. Think of a rank as a relative magnitude, with number 1 being the highest flood ever recorded. If you do it correctly, you should get that the largest flood occurred in 1990. It tells me in order to do this in Excel, I'm going to select all the data in columns A and D, go to Data, Sort, and Sort by Descending. So I'm going to come over to my spreadsheet. Again, I'm going to come over and I'm going to highlight columns A through D. Then I'm going to come up to the Data menu. I'm going to choose Sort, and I want to sort it by the discharge. So I'm going to drop down the menu to Discharge, and I want to go in descending order, so I'm going to go largest to smallest, and I press OK. I know I did it correct because 1990 is the one at the highest flood on record, and it is the one ranked as number 1. Now it says to create a new column and enter the rank as M on the record, meaning I'm simply going to classify them as largest flood as number 1, next is number 2. So I'm going to go over to my Excel spreadsheet again. I'm going to come over here. I'm personally going to call this column rank with the letter M. It's up to you how you want to do that. Then I'm going to tell it that I want this is kind of first place. He's number 1, number 2, number 3, number 4. I don't want to be here the rest of my life. Remember, Excel, one of the benefits of it is that it recognizes patterns. Now I'm simply going to highlight these, and I'm going to pull it all the way down to the bottom, and I'm going to let Excel do the work for me. And you can see that it completely populates all of those ranks. So it tells me there are 93 years on record. So hint, double check your N value and make sure you had 93 as your N value for the number of years. All right, so I'm done with number 2. Number 3 says to create another column and title it R for recurrence interval. And then I'm going to plug in this particular formula. So I'm going to scroll all the way back to the top again. I'm going to be calculating the recurrence value or recurrence interval. So that's what I'm going to call it. It's up to you what you want to call it, but you do need to classify it as something because you will be uploading this to UT. I'm personally going to kind of move this over. It's okay if you have the little restricted there, not a big deal. And it says what I'm going to do is I'm going to compute for every flood the recurrence interval using this formula, where recurrence is N, that was the number of floods on record, plus 1 divided by that ranking that we gave it. It says remember you're using a formula here, so I don't need to put in the letter R. I'm simply going to start it with an equal so the spreadsheet knows to perform a calculation. All right, so I'm going to come right here. I'm going to tell it equals, open parentheses, N. Remember my N value is 93, so I'm going to say 93 plus 1 divided by M, my rank. My rank right here is number 1. So I'm going to put right here, my rank is going to be E4. All right, so right here I'm going to put now all right, so when I do that, I get the number 94. So I'm going to do the exact same thing here. I'm going to put equals, open parentheses, the number of years, which was 93, plus 1, close parentheses, and this time my rank is in E5. So I'm going to put divided by E5. Enter. Now I get 47. I'm going to do that 2 more times just to make sure I'm putting in the formula correctly. Again, 93 plus 1, close parentheses, divided by, my rank this time, number 3, is in E6. I'm going to do it 1 more time. Equals, open parentheses, number of floods is 93, plus 1, close parentheses, divided by, this time ranking number 4 is in E7. And again, you could do this forever and ever all the way down to 93, but I'm going to use Excel to do the work for me. So I'm going to highlight those 4 data points, I'm going to grab it, and I'm going to pull it all the way down to the bottom. And it populates all of my numbers for me. Remember, a recurrence interval is the frequency of a specific magnitude within a length of time. That's what we just calculated. All right, so I just finished this part. So now I'm going to scroll down. Now I'm going to use all that information to make a graph, comparing the recurrence, how often it happens, to the discharge. However, you have to be careful because in Excel, whenever you're making the graph, whatever data is on the left, the computer assumes it's going to go on the x-axis. But unfortunately, within my spreadsheet right now, they're reversed. So I'm going to come over and I'm going to copy discharge versus recurrence. I'm going to use the recurrence, but I need discharge. But discharge right now is on the left, so the computer thinks I want it on the x-axis, but I don't. I want it on the right axis. So I'm simply going to take it. I'm going to copy it all the way down. And I'm going to put it next to my other data that I'm going to use right now. So all I did was copy and paste those cells. You can see 64,400, 64,400 is exactly the same. So now I have my discharge information over here. Now I'm going to use it to create my graph. To create my graph, what I'm going to do is I'm going to highlight both of these columns now. After I've highlighted the columns, I'm now going to come over to Insert because I want to insert a graph. They're going to be checking this when they check your spreadsheet. I'm going to go right here to this one that says Charts. I want a scatter plot. So on first observation, when I look at this particular one, I can see that it is not linear, meaning it doesn't go in a straight line. It's what we call an exponential curve, which means it's a nonlinear relationship, which means I have more small floods than I do big floods, which should make sense. You need to write this down on your particular answer sheet because you will be asked, how does the graph change? What do I mean change? Well, now what I'm going to do is I'm going to come down here, I'm going to double click on the numbers, and another window opens over here. I'm going to scroll down and I'm going to turn it to a logarithmic scale. Notice what happens to the difference between the graphs. Right here it's kind of curvy. When I go logarithmic, now it kind of stretches it out. Again, I can see this is pretty linear down here until it reaches here. Again, simply indicating there's more small floods than there are big floods. That's all that means. All right, so I just changed it to a log scale. So here's where you're going to answer the differences. It says question 2, how does the data change when you change it to a log scale? And what does it tell you about the relationship? I just discussed that. Now we're going to use the chart to determine the discharge amount for both a 10-year and a 100-year flood line. To do that, to help my eyes, I'm going to use a trend line to read the discharge. All right, so I'm going to create a trend line. So I'm going to go back to my Excel spreadsheet. On the Excel spreadsheet, I'm simply going to double click on any of the points. And I know you all can't see it. Let me drop it down here because it comes to a drop-down menu. Sorry, I'm not double-clicking, I'm right-clicking. I'm going to put Add a Trend Line. And it creates a nice trend line for me so I can read the data easier. Typically when you add the trend line, it defaults to a linear. Remember, I want it logarithmic, so I'm going to make sure I'm still in a log, because now I can use my eyes to kind of estimate some of the questions they're asking me on the UT spreadsheet answer sheet. All right, again, you need to make sure your trend line is in logarithmic scale. So now it says, okay, we're almost done with part 1. What is the discharge of a 10-year flood? Then a 100-year flood. How accurate do you think those numbers are? And if you wanted to be more accurate, what data or tools would you need? So this last part for part 1 is pretty easy. I'm simply going to come over. This would be a 10-year flood. I'm simply going to go up. I can kind of hover there. I can click there. I can estimate. I'm going to write that number down on my worksheet for the 10-year. And then I'm going to do the exact same thing for the 100-year about what is that trend that this is showing me. Then based on the information that you use to plot it, you need to decide how accurate do you think that data is. We used quite a bit of data. Remember, we used 93 numbers. Do you think that's pretty accurate? If I want to be more accurate, what tools or data do you think we should have used or needed? All right, so that concludes part 1. Make sure you have questions 1, 2, and 3 answered, and you have that graph saved. So at this time, save your graph.